Okay, can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes.
so I'll just go back a little bit. I need some more slides here. Okay, okay. So, mm, wait a minute. Okay, okay. So the problem that we had started in the last class was that the Marshallian assumption of that the law of diminishing marginal utility holds for all the commodities except for money was replaced by the assumption of diminishing MRS. That is the MRS, which is the slope, will decrease as we increase consumption of X1. Okay. Now, one of the assumptions of the convexity of the properties of indifference curves is that it is convex to the origin. It is negatively sloped and it is convex to the origin. Okay. Now, this is the slope of the curve, and if we take the second derivative, we are going to get the convexity part. Using this second derivative, we can show whether it is convex or concave. Okay. Now, the purpose of our exercise is to show that even if we have, is to show two things basically. First of all, if we assume that the law of diminishing marginal utility holds, this does not ensure that indifferent curves are convex to the origin. And the second thing that we want to prove is that suppose we have convex indifference curves, we can have convexity even without diminishing utility. Okay, so I'll just write this. I'll write it down later. So first, let us find out the expression for uh, convexity or concavity, the second derivative. So using the minus u1 by u2, this is the u by v formula, we can break up this equation. This is mainly we will use this equation and this formula, this rule, and we'll show that the second derivative is equal to this expression. Okay, this one. So up to this one, is it clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, mm, I want to copy this expression. So can you just help me to remember? Okay. Let's see. See, the problem over here is if you make one mistake, you can't cut it out. You can't erase it. U2 by U11. This will be, I hope it's correct. U1 square and U2 2. Now, see, we don't know what the signs will be so far. Okay, we don't know what we know that obviously this u square will be positive or this one will be positive, but we don't know anything else. Suppose indifference curves are convex, then what will be the sign of this? Will it be positive or negative?
Greater than 0.
Positive.
Greater than zero, yeah, positive.
Positive.
Okay. Now we have a negative sign over here. So if you want to cross it out, we can simply write that this part will be negative, right? ঠিক আছে, নেগেটিভটাকে উড়িয়ে দিচ্ছি। Now it will go away. Now let us assume that indifference curves are convex. Okay, so this implies that this term is positive or this term is negative. Okay, this holds. Now, what do we know about U1 or U2?
They are positive.
They are positive. Marginal utility is positive. Okay, so that means if you look at this expression, U cube square, okay, this will be positive because U2 will be is positive. The cube is also positive. Okay, now what is U square? It is positive. Now what is U11? Now here the law of diminishing marginal utility comes in. Okay, if the law of diminishing marginal utility holds, this should be negative. Okay, but if it doesn't hold, well, it can be anything. Okay, so I'm putting a question mark over here. Minus 2, which is positive, this and this. U12 is also positive. Okay, so this is positive, and again U22 is the diminish. We have the law of diminishing utility coming in. So we don't know the sign so far. So plus we can forget about this. So if we keep these, see if U11 is suppose negative,
Sir, you want to is positive.
U12 টা positive. এটা নিয়ে তো কোনো assumption আমি করছি না. And if you think about it, if you increase consumption of one commodity, keeping the other constant, the marginal utility will increase. Law of diminishing utility doesn't come here.
Yes,
Ouch.
sir.
Okay.
স্যার
আচ্ছা
U12টা কেন পজিটিভ হবে আরেকবার একটু বলুন।
আচ্ছা আমি একটু বলছি, জাস্ট এটা আমাকে করে নিতে দাও। আচ্ছা, যদি U11টা যদি নেগেটিভ হয়, তার মানে তোমার ডিমিনিশিং মার্জিনাল ইউটিলিটি হোল্ড করছে, ঠিক আছে? সেটা দুটো it will hold for both commodities, so we will have this, ঠিক আছে? On the other hand, if a DMU doesn't hold, then it will not hold for both commodities. Okay. Is it clear?
স্যার তার মানে যখন আমরা ইনডিফারেন্স কার্ভের মানে কার্ভ করি তার মানে উই আর অ্যাজিউমিং কি এমআরএস হোল্ডস, মার্জিনাল রেট অফ ইউটিলিটি হোল্ডস।
Last part একটু ভেঙে গেল। You are saying that we are assuming that law
তার
of
মানে
utility.
utility still stands while we are doing indifference curves.
না না, সেটা আমি এখনো কিছু বলছি না। I'm going to examine the assumption.
Okay.
What I'm seeing is that if it holds for one commodity, it will hold for both commodities.
Yes sir, yes sir.
এইটুকুনি বলছি, ঠিক আছে?
হ্যাঁ স্যার, হ্যাঁ, থ্যাংক ইউ স্যার।
তার মানে হয় দুটোই আমার পজিটিভ হবে, তার মানে ডিএমইউ হোল্ড করছে, সরি দুটোই নেগেটিভ হবে, ডিএমইউ হোল্ড করছে, আর নয়তো দুটোই পজিটিভ হবে, তার মানে ডিএমইউ হোল্ড করছে না। ওকে, আচ্ছা
Yes sir.
আচ্ছা, নাও let us suppose that DMU doesn't hold. Okay, so in that case, what is the sign of this question mark?
Positive.
DMU তো হোল্ড করছে না, তাহলে U11 পজিটিভ হবে, মাইনাস এই পুরো জিনিসটা পজিটিভ। আচ্ছা, এখানে কি হবে? কোয়েশ্চেন মার্কটা
পজিটিভ।
আগে, আচ্ছা তাহলে সো ইফ ইউ লুক অ্যাট ইট, হোয়াট ইউ হ্যাভ ইজ এই দুটো সাম করলে তো পজিটিভ হচ্ছে, ঠিক আছে, মাইনাস সাম নেগেটিভ ভ্যালু। ওকে, ঠিক আছে। আচ্ছা, নাও সাপোজ দিস ইজ গ্রেটার, এটা তো হতেই পারে, উই ডোন্ট নো দ্য সাম, ভ্যালুস গুলো তো আমি জানি না, এটা তো বেশি, এটা বেশি হতে পারে, এটা কমও হতে পারে। সাপোজ ইট ইজ লেস, দিস ইজ গ্রেটার, তাহলে এটা কি হবে? What is the
নেগেটিভ।
sign? The sign is negative. ঠিক আছে, so we can see that this term becomes negative. We have convexity. So what I'm seeing is that we are assuming that law of diminishing marginal utility does not hold. ঠিক আছে, so we are putting in the values or rather the signs accordingly. So if we simply have এটা কি হবে, u1 square u22, if this is মানে এগুলোর absolute ভ্যালুটা যদি নাও, this is simply less than the absolute value of, let us say, 2u12 u2 u12, ঠিক আছে। what you're saying is this part is greater, তাহলে কি হবে? This will become negative. So without assuming diminishing marginal utility, you can still have convex indifference curves. If this condition holds, right? Is it clear, everyone? U1 2 তো আমি বুঝিয়ে দিচ্ছি। ইজ ইট ক্লিয়ার? বাবা তোমরা আছো না কেটে গেছো?
Yes, sir, it's clear.
স্যার আছি। হ্যাঁ
স্যার ইন মাইক্রো ক্লাস আমরা পড়েছি
হ্যাঁ।
যে ইনডিফারেন্স কার্ভের কনভেক্সিটি এটা এনসিওর করে যে ডিমিনিশিং অফ মার্জিনাল ইউটিলিটিটা হোল্ড করছে।
তোমার কেটে গেল কথাটা।
স্যার মাইক্রো ক্লাসে স্যার আমরা এটা পড়েছি যে কনভেক্স ইনডিফারেন্স কার্ভে মার্জিনাল ইউটিলিটি ডিমিনিশিং
না
মার্জিনাল
একটু
ইউটিলিটি
একটু করে
লটা
বলো।
হোল্ড করে। স্যার মাইক্রো ক্লাসে আমরা পড়েছি
হ্যাঁ
যে
তোমরা ইনডিফারেন্স কার্ভ
কনভেক্স ইনডিফারেন্স কার্ভে ডিমিনিশিং মার্জিনাল ইউটিলিটিটা হোল্ড করে।
কনভেক্স ইনডিফারেন্স কার্ভ হলে ল অফ ডিমিনিশিং
বি মিউটা
ইউটিলিটি
হোল্ড
হোল্ড
করে।
করে। কে
ইয়েস
বলেছে
স্যার,
এটা? এমডি?
ইয়েস স্যার।
না ম্যাম তো এদিন বললো যে উই হ্যাভ অ্যাজিউমড কি মোর আমরা বেশি কনজিউম করলে ইউটিলিটিটা বেড়ে যাবে।
বেশি কম করলে ইউটিলিটি বাড়বে, সেটা তো তোমার পজিটিভ মার্জিনাল ইউটিলিটি হচ্ছে। ল অফ
হ্যাঁ স্যার
ডিমিনিশিং
ওইটাই,
ইউটিলিটি
হ্যাঁ স্যার ওইটাই করেছিলাম ম্যাম।
ওটা ম্যাম যেটা বলেছেন সেটা হচ্ছে সিম্পলি এইটে এইটে সরি what ma'am said is simply this: বেশি কনজিউম করলে ইউটিলিটি বাড়ছে।
ইয়েস স্যার।
এইটা তো ল, হ্যাঁ এইটা তো ল অফ ডিমিনিশিং ইউটিলিটি নয়।
So sir, is it a sufficient condition?
না, so what we have now is this is the necessary condition. We are examining a necessary condition and we have shown that the law of diminishing utility is not a necessary condition. Okay.
Yes sir, I got that. Okay sir.
আচ্ছা এক মিনিট, এটা নেসেসারি দেখালাম না সাফিসিয়েন্ট দেখালাম? হ্যাঁ, it's not a necessary condition.
Not a necessary.
Yeah. আচ্ছা, second is why this is positive. আচ্ছা, এখানে আমরা কি করছি? This is the marginal utility and I'm increasing consumption of x. Sorry, x2. ঠিক আছে, u21 টা কি? This is marginal utility of 2 and I'm increasing x1. ঠিক আছে, আচ্ছা, now think of a marginal utility curve. It can be negative, it can be positive, whatever. I'm just drawing it in this way. ঠিক আছে, so if you're consuming a certain amount of x1, you're going to get u1, right? Now suppose you increase consumption of x2. How will the marginal utility be affected? But think of it in this way, that you are traveling by train. Okay, আচ্ছা, এবার ট্রেনের কোয়ালিটিটা ইন্ডিকেট করছি through using x1. So if the seats are more comfortable, the AC works better, x1 is set to increase. ঠিক আছে, sorry. So you're going to get a marginal utility curve for x1. As x1 goes up, the marginal utility will be something. It can be like this, it can be upward rising, whatever. Yes. So you have a curve. Now suppose along with the quality of the seats and so on, mm, they serve you better food. So let food be x2. Okay. So they give you more meals, the quality of the meals is better. In that case, if you're using this type of diagram, okay, see, you don't have x1 on the axis. So what will be the change? It will simply be a shift in the marginal utility curve. What will be the shift? For the same level of x1, what will happen to the marginal utility? It should go up. Think about it. Shouldn't it go up? Prithviraj?
So,
Yes, sir.
Yes. হ্যাঁ বলো, someone else.
so I just wanted to ask how, if we are consuming more of X2, how the marginal utility of X1 is going up? Like, we are consuming X2 so that because we are attaining greater satisfaction from consuming it, right?
Yeah, but normally it should also affect the utility from x1, shouldn't it? Think about it logically. You're consuming a particular commodity. Okay. See, you're traveling, as I told you, you're traveling along on a train. If I improve the seat quality, which is x1, you're going to get an increased utility. Okay. That is the marginal utility. You have wooden seats, I make it to leather seats. Okay. The quality of the seat goes up, improves, your utility also increases. ঠিক আছে?
Yes, sir.
Okay. Suppose the increase is 5 units, right?
Okay.
আচ্ছা. Now I bring in x2. When you are traveling on the wooden seats, I just gave you ওই চায়ের ভাঁড়ে তোমাকে এক কাপ চা দিয়ে দিলাম, ঠিক আছে?
Mhm.
Now when I'm increasing it to the leather seats, I give you a very nice packet. তাহলে wooden seat থেকে তোমার এই যে ইনক্রিজ ইন ইউটিলিটি হলো, সেইটা বেশি হবে না কম হবে?
বেশি
তোমার
হবে।
মানে তোমার যে খাবারটা, the
হ্যাঁ
quality
হ্যাঁ
of the food x2, that is
হ্যাঁ
going
বুঝতে
up,
পেরেছি।
is going to enhance your x marginal utility of 1.
থ্যাংক
Okay.
ইউ স্যার।
So আচ্ছা, and obviously the reverse is also true. u1 to যদি করো u21 তো একই জিনিস হচ্ছে। আচ্ছা, ঠিক আছে, তাহলে এখানে so what I've shown over here is that even if we don't have law of diminishing marginal utility, we can still have convex indifference curves. In that case, we need a condition. This is the condition. Okay. So if it satisfies, if it holds, we don't need diminishing marginal utility. Okay. Now, okay. Now let's go to the other thing. So this is the term. আচ্ছা, Let us assume that the law of diminishing marginal utility holds. So what does it imply? It implies that they are, both of them are negative. Okay. So that means, sorry, এখানে একটা নেগেটিভ ছিল, এটা তো u স্কয়ার, this is positive. আচ্ছা, এইটা কি? This is positive. What is u11?
নেগেটিভ।
নেগেটিভ।
ওকে, এই পুরো এক্সপ্রেশনটা কি?
পজিটিভ।
ব্র্যাকেটের ভেতর ইটস পজিটিভ। আচ্ছা, এইটা হলো তোমার পজিটিভ, এইটা নেগেটিভ হচ্ছে। আচ্ছা, এখানে দাঁড়া দাঁড়া, তোমার এটা কোথায় গেল? This has to be positive, right? পেনটা না হারিয়ে যায়। আচ্ছা, ওকে, তাহলে তোমার এই দুটো সাম করলে নেগেটিভ হয়ে যাচ্ছে, আর সরি এই টার্মটা আছে। আচ্ছা, আচ্ছা, এইটা নেগেটিভ দেখাতে গেলে, সরি এটা পজিটিভ দেখাতে গেলে দিস হ্যাজ টু বি নেগেটিভ। তাহলে এই ব্র্যাকেটের টার্মটা শুড বি ওকে। হ্যাঁ সরি, আমি একটু এই স্লাইডে ভুল বলেছিলাম, সরি। এখানে সরি, সরি, দিস ক্যান বি আইদার পজিটিভ অর নেগেটিভ, ঠিক আছে? আমরা এইখানে we are making two assumptions. First is this, and the second assumption is this is positive, ঠিক আছে? আচ্ছা, এইখানে আমি ধরে নিচ্ছি যে this is negative, so this becomes negative, so নেগেটিভ নেগেটিভ, এটা একটা প্লাস টার্ম হয়ে যাচ্ছে। আচ্ছা, সো মানে হিয়ার अगेन
Sir, could
ডিপেন্ডিং
you
অন,
show the previous slide? যেটাই আপনি correction
আর্লিয়ার স্লাইডে আমরা ধরছি সরি এটা 1 2 হবে, হ্যাঁ ওকে। আচ্ছা, তাহলে যেটা হচ্ছে I have a negative term and I have a positive term. Again, depending on the value of this term, right? This bracket can be this bracketed term can be positive. So what is this? This becomes negative. So which implies that the indifference curve is not convex. ঠিক আছে? So in this slide, what we have done is we have assumed that U11 and U2 are negative. That is law of diminishing marginal utility holds. But if two conditions hold, one is U12 is negative, and second, U square U112 is the absolute value. Positive জন্য আমাদের এটা ধরতে হবে। So if this
স্যার
is
অপোজিট হবে না?
দাঁড়াও, এইটা যদি পজিটিভ হয়, no, I want this to be the bracketed term to be positive. তাহলে কি হবে? এই কন্ডিশনটা হোল্ড করবে না? অয়ন?
স্যার ফর নন কনভেক্স?
হ্যাঁ।
ইয়েস স্যার, ইয়েস।
আচ্ছা। So if this condition, if these two condition holds, indifferent curves will not be convex. So we have the law of diminishing marginal utility, but still indifferent curves need not always be convex. That is, DMU is not sufficient for convexity. ঠিক আছে? Can I just run the slide?
স্যার দুটো কন্ডিশন সাইমালটেনিয়াসলি হোল্ড করতে হবে, তাই তো?
হ্যাঁ।
ওকে স্যার।
মানে বেসিক্যালি যেটা হচ্ছে, if you look at it, what you have over here is a set of three terms. ঠিক আছে? এই টার্মটা আর এই টার্মটা স্ট্রাকচারালি সেম। ঠিক আছে? So what happens is, if you have diminishing marginal utility, this will become negative. Okay? কিন্তু এইটা যদি তোমার পজিটিভ হয়, সরি, মানে এই ব্র্যাকেটেড টার্মটা যদি নেগেটিভ হয়ে যায়, and if it is larger, then the curve, the convexity assumption will be violated. ঠিক আছে? On the other hand, in this case, what we are showing is, again, if certain condition holds, the sign of this is not relevant. এইটা যদি ধরো dominate করে, if it is larger, if it is negative, but these are negative, but these are very large, you'll automatically get, and these terms are small, then you're going to get this term to be negative. So the convexity assumption will hold. The curve will be convex even if you don't assume that law of diminishing mu holds. Okay, you can read two things, Henderson quant or Silverberg. You will see that in Silverberg, several variables, page 52. Page 52 and page 53. So you will see that the proof is discussed. So basically what we have is this one, U12. What is the sign of U12? And what is the value of U12? এখানে দেখো U12 টা নেগেটিভ হচ্ছে। ওহো। আর এইখানে দেখো U12 টা পজিটিভ হচ্ছে। ঠিক আছে? So that is one thing. What is the sign of the cross partial derivatives? And secondly, what is the magnitude of this term? In particular, what is the magnitude of U12? If it is sufficiently strong enough, then we can see that this cross partial derivative is important, not the sign of U11. Whether it is positive, whether it is negative, whether DMU holds, it doesn't hold, it doesn't matter. U12 will determine whether the indifference curve is convex or not. Okay. তোমরা তো চুপচাপ আছে কেন আজকে? Cat run away with your tongues.
No, sir. So we are consuming all of this.
So you're consuming as the cat consumes the mice.
Sir, this is a bit like
It's a very difficult topic.
yeah.
আচ্ছা ঠিক আছে, যেটা আমি করবো, I won't be able to do it this Sunday. এটার উপর একটা যদি নোট বানিয়ে দিই আলাদা করে, will it help?
হ্যাঁ স্যার,
Yes, sir. Yes, sir.
Yes, sir.
So that
Yes,
will be
sir.
very
Yes, sir. Yes,
helpful.
sir.
খুব ভালো।
Yes, sir. Yes, sir. 3 packs full. Who said it? Acha. The second part is important thing that I want to discuss today is the monotonic transformation. I think we have discussed this in the earlier classes. Basically, monotonic transformation bolte we are talking about functions like log, square, where what happens is simply the value of y goes up. তার মানে basically, if I'm mapping, ধরো x1 দিলাম, তার একটা corresponding y1 হলো, x2 দিলাম, তার একটা corresponding y2 হচ্ছে. Let us suppose it's a positive relation. So what is the relation between y1 and y2? Which is greater? ধরো it's a positive function, মানে x বাড়লে y বাড়বে, তাহলে কোনটা
Yes, sir.
বেশি
Y2
হচ্ছে?
is greater.
y2 is greater. আচ্ছা, now this is based on a functional relation y as a function of x. So suppose we take a monotonic transformation. So that means we still have y as a function of x, but the functional form is different now. ঠিক আছে? gx is a new type of function. আচ্ছা, now under gx, if you still have this property, ঠিক আছে, then we say that g is a monotonic transformation. মানে যেটা বেসিক্যালি হচ্ছে যে এখানে এই ফাংশনের ফলে তোমার y এর ভ্যালু গুলো বেড়ে যাচ্ছে, কিন্তু ওদের অর্ডারিং গুলো চেঞ্জ করছে না। ওকে, সো y value is increasing under g, but the ordering is same, remains same. তার মানে ধরো তোমার y1 হচ্ছে 5, y2 হচ্ছে 7, ঠিক আছে? তাহলে তুমি যখন x1 দিচ্ছ, তুমি y কত পাচ্ছ? 5 পাচ্ছ। x2 দিলে কত পাচ্ছ? ধরো 7. So this is the relation. যখন তুমি g তে যাচ্ছ, for x1 you're getting 10, for x2 you're getting, let us say, 12. দেখো অর্ডারিংটা তো একই থাকছে। So this is a positive monotonic transformation. Negative monotonic transformation কি হবে?
x1 is greater than x2, তাহলে
হ্যাঁ
y1 is lesser than y2.
হ্যাঁ, এইটা দিয়ে আমি স্টার্ট করছি। তাহলে এই র্যাঙ্কিংটা মানে y2 should always be less than y1, ঠিক আছে? এইটা হয়ে যাবে। So monotonic transformation implies that the ordering is same. আচ্ছা, এখানে একটা এক্সাম্পল দিতে পারবে এই 5 7 এটাকে ইউজ করে? না, নেগেটিভ, সরি তুমি পৃথিবী একটু ভুল বললে। নেগেটিভ মনোটনিক ট্রান্সফরমেশনটা হচ্ছে যে সাপোজ দিস রিলেশন হোলস, ঠিক আছে? সো ফর x1 we have 5, if you put x2 we will get 7, ঠিক আছে? পজিটিভ রিলেশনটা থাকছে। When I'm going to g, what happens? The value of y is decreasing. তার মানে x1 যদি আমি দিই, বসাই, I'm getting a value of 3 for y. And if I put in x2 into this function, what will I get? Not 7, but a lower value. ঠিক আছে? So that means if it is a negative transformation, y is scaled down. All the values of y is reduced. If it is a positive transformation, all the values of y are increased. ঠিক আছে?
মানে as x increases y increases, এটা হচ্ছে পজিটিভ মনোটনিক ট্রান্সফরমেশন। আর যখন x increases y decreases, সেটা হচ্ছে নেগেটিভ মনোটনিক ট্রান্সফরমেশন।
না, ঠিক আছে? This is a function. What is the relation between y and x? It's a positive relation. ঠিক আছে? ওকে, তাহলে y equal to x যদি নিই, y এর ভ্যালু গুলো কত হচ্ছে? It will be same. Okay. আচ্ছা, now the new function is this is a monotonic transformation. Okay. এখানে কি হচ্ছে? What is the value of y? The new y?
1, 4, 9, 16, 25.
ওকে, তাহলে এদের মধ্যে যে রিলেশনটা, অর্ডারিংটা, দ্যাট ইজ সেম।
হ্যাঁ।
আচ্ছা, নাও লেট মি টেক দিস। ঠিক আছে? So what we have is if x increases, y decreases. না, এটা করলে একটু অসুবিধা হবে।
1 by x নিন।
1 by x করে নি। আচ্ছা, তাহলে এখানে তিনটেই ধরি। এটা কি হচ্ছে? 1
1, 1 by 2, 1 by 3.
1 by 3। ঠিক আছে? এইটা করলে কি হচ্ছে?
1 by 4, 1 by 9.
1 by 9। ঠিক আছে? What is happening to the ranking?
Ranking
যত
same.
আমরা x বাড়াচ্ছি, y এর ভ্যালুটা ফল করছে। ঠিক আছে? এটাকে আমি y প্রাইম বলছি। What is happening to y prime? That is also decreasing. ঠিক আছে? Now if you look at it, এইটার এটা if you compare করো, সরি, এটা অ্যাকচুয়ালি কিন্তু this is not a
Monotonic transformation.
হ্যাঁ, সরি, না, এই পেনটা না, যদি আমি এরকম করে দিই,
hundred by x square.
হ্যাঁ,
x square থাকবে তো?
হ্যাঁ। So what is happening? Y, as you are increasing, as you are going down, as x is increasing, y prime is falling. তাই তো?
হ্যাঁ।
ঠিক আছে? But look at, compare between y and y prime. In each case, এইটা হচ্ছে simultaneously.
Not for the first case. Not for the first case.
In the first case, what you have is this. না, এখানে কি হচ্ছে?
না, আমি ডান দিকের কথা বলছি। ওই যে y equals to 1 আর ওখানে y prime equals to 100.
এখানে কি হচ্ছে? এখানেও তো আমার এরকম হচ্ছে।
হ্যাঁ,
তাই না? y prime is always larger than y. The transform value is always larger than the original y. ঠিক আছে? So that is the positive monotonic transformation. Monotonic transformation means ordering is same, and the positive means this relation, this part.
ওকে, আচ্ছা বুঝেছি। হুম।
Hmm. আচ্ছা। If it is a negative, if it is a negative monotonic transformation, see, monotonic means the ordering is unchanged, and negative means y is greater than y prime. Okay. You can think of it in this way. আবার ওটা নিলাম. Well, let us make it 2x. So this becomes 2, this becomes 4, this becomes 6. And y prime is 2x minus 5. তাহলে কি হচ্ছে? It is minus 3, minus 1, 1. ঠিক আছে? So what is happening is, as x is going up, y is increasing, but look what has happened. Y is greater than, this is larger than this. দেখো র্যাঙ্কিংটা কিন্তু সেম, 2 is less, 4 is greater, 6 is greater. এখানে -3 থেকে -1 বড়, +1 is greater. If you take 4, this will be 8, this will be 3. Okay, but the transform value is less than the original value of y. So this is a negative transformation. বুঝতে পারলে? y এবং x এর মধ্যে রিলেশন কিন্তু ইম্পর্টেন্ট নয়।
আচ্ছা,
Positive or negative means the relation between y and y prime. আচ্ছা, পৃথ্বীরাজ তো বুঝলো, বাকি?
স্যার আমি শুভায়ন।
ও শুভায়ন, ওকে সরি।
হুম।
তোমার গলাটা অনেকটা পৃথ্বীরাজের মতো। পৃথ্বীরাজ বুঝেছো?
ইয়েস স্যার।
আচ্ছা। অর্পিতা, চানক, অদিতি, গাইন, বাঘাবাইন, আছে তুমি?
So she won't be attending the class. She had
আচ্ছা, আর বাঘাবাইন? সামাদ গাইন ও আজকে আসেনি। আচ্ছা, ঐন্দ্রিলা বুঝতে পারছো? খুশি?
Yes, sir, understood.
খুশি প্যাটেল? Okay. Okay. Now the point that I want to make is, see, in case of the Higgsian utility theory, the utility function simply ranks the preferences. Okay. So if we have a commodity bundle indicated by x1 and another commodity bundle indicated by x2, we simply say that x2 is preferred to x1. Okay, we don't say by how much it is preferred. It can be maybe the first bundle yields me 2 units of utility, maybe it yields 3 units, I don't know. Now, one important implication is that it is possible to take a monotonic transformation of the utility function. So, if we have the utility function u as a function of x1, x2, we can simply take a monotonic transformation f prime of u positive. This is a positive monotonic transformation, which means that for the same utility bundle, you get more satisfaction. What will be the negative monotonic transformation? This will be f prime is less than 0. See over here. Monotonic transformation, we preserve the ranking. If it is an increasing monotonic transformation, f prime is greater than 0. So for every bundle, we are getting more and more utility. If it's a decreasing or negative monotonic transformation, f prime is negative, which means that each bundle will yield me lower amounts of utility. But the relation between the bundles remains the same. Now, the best example, the easiest example of a positive monotonic transformation is a log transformation. So we can simply put in this utility function, and if we take log, we are going to get this type of function. So what happens over here, if you put in values of x1 and x2, your result will change. V is different from U. But the important thing is that for a particular bundle, or if you want to compare across bundles, U1 is greater than U2 implies V1 is greater than U2. Okay. So the relation between the bundles, which bundle is more preferred, which is less preferred, that remains the same. Now, if you have a monotonic transformation, we like this, using the chain rule, dx1 dv by dx1 is can be written as del x1 by del u into del u d del v. Okay, so which is simply f prime into this is u1. For v2, it will be simply f prime u2. Okay. Now tell me one thing. What we have done was, I'm writing down what I've told you. Okay. Now, what is the equilibrium condition for a consumer who maximizes utility? It is
Budget
marginal
line.
rate of is equal to P1 by P2, right? This is slope of the budget line. This is slope of the indifference curve, right? Now, what is MRS? It is U1 by U2, and which is equal to the price ratio. Now, if you take V1 and V2, will the equilibrium change?
No, sir.
Why?
So the ratio will be same. V1 by V2 is equal to E1 by E2. F dash আর
Okay.
F dash কেটে যাবে।
So we have MRS1. This is F prime U1 F prime U2, which is sorry the minus dash, which is simply U1 by U2. So is the equilibrium condition changed? It is not. F প্রাইমটা কেটে দিলে তো আমি ঠিক আগের কন্ডিশনটাই পাচ্ছি। Okay, so if we have the same condition, the equilibrium point will also be the same. Okay, right? So if you take a positive monotonic transformation, it will not affect equilibrium. আচ্ছা, রৌনক, are you there?
হ্যাঁ স্যার।
হ্যাঁ, আচ্ছা, যদি ধরো আমরা একটা নেগেটিভ মনোটনিক ট্রান্সফরমেশন নিই, তাহলেও কি ইকুইলিব্রিয়াম আনচেঞ্জড থাকবে?
হ্যাঁ স্যার।
তোমার কি মনে হয়?
স্যার আনচেঞ্জই থাকবে।
আচ্ছা, আনচেঞ্জ থাকবে কারণ আমি তো এফ প্রাইমটা বাদ দিয়ে দিচ্ছি। এফ প্রাইম ইজ সেম both in the numerator and denominator. It can be positive, it can be negative.
নেগেটিভ, হ্যাঁ
ঠিক
স্যার।
আছে, it doesn't matter. It is going to cancel out. Right? So, what is important is whether the transformation is monotonic or not. If it is not,
Sir, your voice is breaking.
yes.
Like, I could not get the last part you said.
Yes, sir, your voice is
Yes,
breaking.
sir.
Okay, sorry. What I said was that these f primes are going to cancel out, right? So whether this f prime is negative or positive, is it relevant?
No.
No.
No. So whether it, now why is f prime important? F prime indicates whether the monotonic transformation is positive or negative. Okay. So we can see that it doesn't really change the equilibrium condition. Whether it is positive, whether it is negative, f prime is going to get cancelled out. So the important thing is whether it is a monotonic transformation or not. Right? So look at this. Just check for this example. We have, this is the original utility function and this is the budget line. Okay. এখানে আমি xy দিচ্ছি তাহলে একটু সুবিধা হবে।
So, was
Let
there
us
any intuitive meaning to that?
to what? Intuitive meaning to what?
No, sir, I was confused. I got it.
Okay.
The f primes being negative, positive, how it doesn't affect that
Yeah.
part.
Okay. So suppose your utility function is this, okay, and this is your budget line. What is U1? Rajashree Khan, are you there?
Yes, sir.
হ্যাঁ বলো তো u1 কি হবে?
So 0.5 x to the power
হ্যাঁ
minus 0.5.
আচ্ছা তাহলে নিচে পাঠিয়ে দিই।
Yes, sir.
আর
Into y to the power 0.5.
আচ্ছা u2
X to the power 0.5.
আমি যেটা ছিলাম গুগল গু I don't think that's the answer.
No, sir. X to the power 0.5 into 0.5 into y to the power minus 0.5.
এইটাই তো?
Yes, sir.
আচ্ছা so what is MRS?
So u1 by u2.
তাহলে এখানে কি হবে? 0.5টা কেটে যাচ্ছে।
Yes, sir.
আচ্ছা তাহলে এটা হচ্ছে
The minus y by x.
হ্যাঁ
Yes, sir.
মাইনাস
Y by x.
আচ্ছা this is equal to the price ratio which
Yes,
is
sir.
-1. দুটো প্রাইস তো 1 হচ্ছে। তাহলে এটা y by x equal to 1 or y equal to x, ঠিক আছে? So substitute this. তাহলে x কত হচ্ছে? or rather x টা
So 5. So
আচ্ছা,
even y should be 5.
even y will be equal to 5. আচ্ছা now put x equal to x star equal to 5. We get 5 plus y equal to 10 or y star is equal to 10. Okay, so this is the original this is the utility maximizing bundle. Now let us take a positive monotonic transformation. Log of u. এইটা কি হবে বলো? How will we write this? এইটা আগে বলো। Let's do it step by step.
0.5 log.
আচ্ছা ঐন্দ্রিলা, are you
0.5
there?
log x plus 0.5 log y.
দাঁড়াও। আচ্ছা তাহলে u1 কি হবে?
0.5 by x.
u2 is
0.5 by y.
MRS is
Minus u1 by u2. So it will be minus y by x.
0.5 by x minus y by x, right?
Yes, sir.
MRS is equal to price ratio which is equal to 1, right?
Yes, sir.
So ঠিক আছে? So what
Yes,
will be
sir.
x star y star?
It is going to be the same 5 and 5.
So if you put it, it's going to be still 5 and 5. Okay, so we can see that if it's a, let's say, a log transformation, or suppose we take square of these transformation, these are all positive monotonic transformation. In that case, the utility will not be affected. If we suppose we take the square root of u, what will happen? Rajeshi?
So root of what? Could you repeat?
Okay. Root of utility. So V is now this. In the earlier case, it was V was log of U. Now I'm taking root of U. What will happen to the bundle?
Same.
So same.
Transformation.
This is a positive monotonic transformation. This is simply a negative monotonic transformation. Okay. But since we are taking a monotonic transformation, the equilibrium will be unaffected in both cases. Okay. Now, I'm going to take the same utility function. Okay. So it was right. But now let us say the budget line is this. সরি এটাকে বলছো তুমি 36 করে নাও। What will be the equilibrium?
Price ratio হয়ে যাবে -1/5.
So P1 is -1/5. So if we equate them, we get minusটা আমি change উড়িয়ে দিচ্ছি।
5y equals to x.
Equal to x.
তাহলে 5 into 5y 25y plus y 26y equals to 36.
236. 2y equal to 36. Or y equal to 18 হয়ে গেল, তাই তো?
No.
25.
25y plus y 26y equals to 36.
5y. আচ্ছা, x is equal to sorry.
স্যার p1 by p2 টা -5/1 হবে না?
Yes.
Yes, sir, -5 only.
স্যার y 18 ই হবে।
হ্যাঁ, সরি আমার একটু না এই স্লাইডটা আমি ডিলিট করে দেবো তাহলে। আচ্ছা, তাহলে তোমার u1 u2 হচ্ছে 8 let's keep it to 40. আচ্ছা, সরি, তাহলে প্রাইস রেশিওটা হচ্ছে p1 p2 is 5/1. So the consumer equilibrium is y by x equal to 5/1, or y is equal to 5x. Okay, so if we substitute, we get 10x equal to 40, তাই তো? Or
Yes,
x
sir.
equal to 4. আচ্ছা, তারপরে যদি এখানে 4 বসাই, I'm getting 20. So y is equal to 20. ঠিক আছে? আচ্ছা, এখানটা so this is the equilibrium bundle. আচ্ছা, সব সময় কিন্তু এখানটা বলে নেবে, assuming that second order conditions are satisfied. You don't have to find it out now. আমি তোমাকে করায়ও নি, সবসময় এটা আমি করাবো না এই সেমিস্টারে, but always write this. Whenever you're doing a maximizing exercise, either you show that the second order condition is satisfied or you write it. আচ্ছা, এইবারে ধরো আমরা প্রাইস এবং ইনকাম দুটোই আমরা ডাবল করলাম, ঠিক আছে? তাহলে P1 হচ্ছে 5টা হয়ে গেল 10, P2 becomes 2 and M becomes 80. So the budget equation is but the utility function is the same. Barker, what is the equilibrium condition now?
Same, sir.
সেম থাকবে।
Others? Messi?
Yes, sir.
Same, sir.
Same থাকবে।
Same, sir.
Okay.
সেমই থাকবে স্যার।
তাহলে আমরা কি দেখছি? If prices and income all increase or decrease by the same proportion. Okay. তার মানে prices increase দুটো একই দিকে চেঞ্জ করছে, either all of them increases or all of them decreases, and the increase or decrease, the change is by the same proportion. So what we can say is they go up by lambda. এটা greater than 1 হতে পারে, it's increasing, it can be less than 1, it's decreasing. So if this happens, what happens to demand? Demand will increase.
No sir, it will remain same.
Remain same.
Demand will be unchanged. Now if you write the demand function, this is a function of P1, P2 and M, own price, cross price and income. So what we are basically saying is that this is equal to right? The value of Q over here is same if you have P1, P2, M, or if you have lambda P1, lambda P2, lambda M. Demand is unchanged. Can I write this? This property is called
Homogeneous.
homogeneity of degree 0 in prices and income. 0 is important. 0 means it's unchanged. And the reason is that suppose you have a function y as a function of, let us say, x1, x2, xn, if we change this vector by lambda so that it becomes lambda x1 to lambda xn then y becomes lambda ny. Okay. Okay. In other words, for y equal to okay, lambda to the power of n then y is said to be a homogeneous function of degree 0. So in this case, what was the demand function? What is the demand function? Demand is a function of P1, P2, and M. If we simply say it is homogeneous, what does it mean? It means this, right? Now, in our exercise, what did we show? What is the value of n? It is 0. Okay? So demand functions are said to be homogeneous of degree 0 in income and prices. Now, using this homogeneous function, there's a theorem, Euler's theorem. Do you know what this is? Okay. This is simply this. Okay. So I'll prove this later on in the next class, but this is what we call what is Euler's theorem. And this is something that is going to be very useful later on. Now, using Euler's theorem, we can, and these properties of homogeneous function, these relations, we can prove different, some very small but very interesting results. Okay. Acha, how far has MD covered in the utility part?
Hicks and Slutsky was covered in the last class.
The substitution effect?
Yes, sir.
Substitution. So what is the sign of the substitution effect? Whole price
Negative.
substitution?
It is negative.
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 Okay. Okay. Uh,
She did income effect as well. She did both of them together.
okay. Let's see, there are small theorems. Can I remember? আচ্ছা না ছেড়ে দাও, ওটা একটু আমাকে দেখে নিতে হবে। Now let me discuss something else. Or before going to that, see, I had used the form this, right? Utility is a function of x1 to the power of alpha, x2 power of beta. Now, this is also used in production. In production, we write this as in this form, where alpha, beta, and a are all positive. Now, what is the name of this production function? Do you know?
Production function.
স্যার এটা
Why
একটা
is it called
কনস্ট্যান্ট
এটা? A
একটা
is constant.
আচ্ছা ঠিক আছে
You can interpret E to some extent as technology. Actually, alpha beta technology represent করে. আচ্ছা। Now, do you know why it is called Cobb-Douglas?
No.
And please don't say it was invented by Cobb and Douglas.
No, sir.
It was.
Sir,
It
they
was
calculated the national output.
the national output. No, not so dramatic. See, what happened was Cobb was an economist. Okay. And he was working with some production functions. And he wanted to show, he wanted to find out a production function which would satisfy certain conditions. Okay. Let me find out the conditions. Sorry, just give me 1 minute. Yeah. So, okay, he wanted to find out a production function which would satisfy certain properties. The property was that the production function will be homogeneous of degree alpha plus beta if alpha plus beta is equal to 1, it will become linearly homogeneous, in which case it is going to satisfy some additional properties, which I'll discuss. And 3 is, I'm going to, isocons are what should it be? Isocons are
Downward sloping, convex to origin.
Downward sloping. Negative.
negatively sloped and strictly convex to the origin. And 4, it is strictly quasi-concave for positive values of L and labor and capital. Okay. So he wanted to find out a production function which will satisfy these four properties. And he was experimenting with different types of production functions. But in some cases, 3 was being satisfied, but not 4. 2 was being satisfied, but not 4, and so on. So after a few days, he went to his university cafeteria and he was sitting very morosely. He was just picking on an excellent um, lunch, but he was not really enjoying it. Now, in that table, by an accident, Paul Douglas was also sitting. Paul Douglas was not an economist, he was an engineer. And he didn't know Cobb. But he looked at this person, there was an excellent lunch, but he was not enjoying it. So he asked that, look, something seems to be bothering you. What is it? He said, look, I've been working on this problem for the last few days. I want a production function which will satisfy these four properties. So Douglas said, what properties? And luckily, the napkins that they were using were made of paper. So Cobb took out a napkin and he wrote on the paper these 4 lines. And Douglas looked at it and said, oh, and I know a function which will satisfy all these properties. He said, what? What type of function? And Douglas wrote this. Q equal to A L to the power of alpha, K to the power of beta. And then Cobb got very surprised. He went back and checked and he found that this form really did satisfy all the 4 properties. And being a very generous person, he wrote a paper, and in that paper, he took Douglas as the co-author. And from thereafter, this type of function is called Cobb-Douglas function. Okay. Now, let us see whether Douglas was right or wrong. Okay. So we take the first proof, homogeneous of degree alpha plus beta. How do we prove whether it is homogeneous or not? We have to increase both L and K by the same amount. So change labor into lambda K, capital into lambda K. So what is Q? Right? If I pull out lambda, what do I get? ঠিক আছে?
So lambda to the power alpha plus beta.
Lambda to the power of alpha plus beta. Now what is this? Can I simplify this? এইটা কি হচ্ছে? এটা তো Q হচ্ছে, তাই না? এই পার্টটা? This is simply Q.
Yes, sir.
Yes, sir.
So what is the degree of homogeneity?
Alpha plus beta.
The power of lambda. This is the degree of homogeneity. So the first proof is there. আচ্ছা, এবার alpha plus beta যদি 1 হয়, this obviously becomes lambda Q. So it is linearly homogeneous. Now, how do we prove that it's negatively sloped? dl by dk has to be negative, right? So q is equal to now an easy way of doing this is take log. Sorry, এটা k হয়ে যাবে। ওকে, আচ্ছা এবার লগ কিউ কে তুমি জাস্ট কি করবে, ক্যাপিটাল কিউ করো, এটাকে তুমি জাস্ট একটা এ করে দাও, থিটা করে নাও, ইটস কনস্ট্যান্ট। ঠিক আছে, যেখানে ক্যাপিটাল কিউ ইজ ইকুয়াল টু log q and log a is equal to a, let's say. আচ্ছা, now take the total differential. We have dq is equal to dA, alpha is constant, এটা হচ্ছে log l by dl. Now what is dq?
0 along the isoquantity.
Okay, so this is also 0, and what is dA? dA is a constant, that is also 0. ঠিক আছে, so what is, এটা তোমার dk by dl হবে। What is dk by dl? এটা আমার একটা ভুল হয়েছে, it should be dk by dl. So what is dk by dl?
So alpha by beta into k by l. So there would be a minus sign.
There will be a minus sign. Now all the four terms are positive, so this will be negative. ঠিক আছে, আচ্ছা, now what is the second derivative? আলফা বিটা মাইনাস, এটা বার করে নিচ্ছি। আচ্ছা, okay, so this is L square. আচ্ছা, this is L into dk dl minus k into dl by dl. ঠিক আছে, তাহলে এটা হয়ে যাচ্ছে তোমার 1 by L dk dl, আর এটা হচ্ছে k by L স্কয়ার। ঠিক আছে, আচ্ছা আলফা বিটা হচ্ছে তোমার পজিটিভ, 1 by L তো পজিটিভ, dk dl টা কি নেগেটিভ, দিস ইজ পজিটিভ। ঠিক আছে, তাহলে এই পুরো ভেতরের টার্মটা নেগেটিভ হয়ে যাচ্ছে। So the second derivative is positive. So what does it imply? It implies that the isocones are convex to the origin. Okay. Okay. Now, I had said, if you look at this, I had said that if it is linearly homogeneous, it is going to satisfy some additional properties. So, what are these additional properties? So, I'm just going to write them down. So, suppose we have a linearly homogeneous production function. This is homogeneous of degree 1. Then the average product of the inputs, labor and capital, will be functions of K, when K is defined as, so this is the capital labor ratio. Okay. The second product is, property is MPL and MPK are also functions of small k. The third is so these are the marginal products is equal to Q. Okay. So these are the three properties, and I'm not going to discuss this. You have to check this out in Chiang. Pages 412 to 417. Okay, if you have a problem, I'm going to discuss this. 412, 4113, he has just discussed these three properties. Subsequently, he's discussed the Cobb-Douglas properties, and then whether if the Cobb-Douglas is linearly homogeneous, does it satisfy these three properties or not? Now, the third property, which obviously you can recognize as Euler's theorem, has a very important result, and I'm going to close today's class with this implication. Suppose inputs are paid at a rate equal to their marginal products. So in that case, how much will capital be paid? What is R, the price of capital? It is simply MPK. And how much is labor paid? Labor is paid W, which is equal to MPL. So if you substitute this over here, KR plus WL, we get, so the entire product, the value of the product is exhausted. Okay. So that means if they are paid MP and we just multiply them by the product, that is conceptually easier to understand. We are simply going to get, that means what is this? This is simply the total revenue. So whatever the producer earns by selling the product, the entire part is exhausted if you simply pay according to, we call this VMP, value of marginal product. This is called the product exhaustion theorem.
স্যার এই জায়গাটা বুঝলাম না। Inputs are paid at their marginal productivity.
Value of marginal product. মানে ধরো তোমার মার্জিনাল প্রোডাক্ট যদি 5 হয়, এটা তো কোয়ান্টিটি টার্মসে হচ্ছে, তুমি প্রাইস টার্মসে ভ্যালু টার্মসে কিভাবে নিয়ে আসবে? প্রাইস দিয়ে মাল্টিপ্লাই করে। ঠিক আছে, তাহলে P ইনটু MPK। আচ্ছা, এবার সাপোজ আই এম আ ওয়ার্কার, আমার মার্জিনাল প্রোডাক্ট হচ্ছে MPL, ভ্যালু টার্মসে ইটস P ইনটু MPL। ঠিক আছে, and what is K and L? This is the amount of capital that you are supplying. L is the amount of labor that I'm supplying.
টোটাল প্রোডাক্ট, আচ্ছা টোটাল প্রোডাক্ট ইনটু প্রাইস টোটাল রেভিনিউ হয়ে যাচ্ছে।
হ্যাঁ, তোমার যে টোটাল এখানটা হয়ে যাচ্ছে তোমার টোটাল কস্ট, তাই তো হচ্ছে। লেবারকে তুমি কতটা দিচ্ছ, ক্যাপিটালকে, পেমেন্টস টু লেবার এন্ড ক্যাপিটাল, that is your cost. So your entire output, your entire revenue is exhausted.
আচ্ছা, মানে টোটাল প্রোডাক্ট ইকুয়ালস টু টোটাল কস্ট, আর টোটাল রেভিনিউ ইকুয়ালস টু টোটাল কস্ট হয়ে যাচ্ছে।
হ্যাঁ,
আচ্ছা ঠিক আছে, বুঝেছি।
হ্যাঁ, এবার তুমি যদি প্রাইস টার্মসে না করো, ইউ হ্যাভ টু সে দ্যাট, মানে ওদেরকে জাস্ট ওরা, আমরা এলাম প্রোডিউসারের কাছে, হি জাস্ট পেজ মি পার্ট অফ দ্য আউটপুট, কিছু ইউনিট দিল, দেন দ্য এন্টায়ার প্রোডাক্ট ইজ এক্সহস্টেড। মানে এখানে প্রাইসটা আমি আনলামই না ধরো। ঠিক আছে, দেখো প্রাইসটা তো ক্যান্সেল করে যাচ্ছে না, so the entire output will be exhausted.
আচ্ছা,
So that means if it's a linear production function, capital and labor is going to take away, আর যদি আর কোনো ইনপুট থাকে, that is going to take away all the profit, all the output. So what is the profit in this case?
Zero.
It is zero.
Normal
What we
profit.
say is they get normal profit. SM তোমাদের কতটা পড়িয়েছে গো? পারফেক্ট কম্পিটিশন স্টার্ট করেছে?
Next class she will discuss normal profit and supernormal profit.
Okay, great. So what happens over here is there's no normal profit. If you want, you can simply introduce some, the producer also as an input, and he also gets an part of the output, which is equal to his normal profit. Okay. So I'm ending today's class. Achha, tomorrow, after I have some work from 11:30. Can you start at about around 9:45? or in the evening,
Yes, sir.
whichever you prefer.
So 9:45 is fine.
Yes, sir.
Okay. Okay. So I'll send a temporary link for tomorrow's 9:45.
Sir, could it be in the evening?
সেটা তোমরা ঠিক করে নাও।
Sir, can we mail you after this class after discussing?
Okay, I'll log out then. You can discuss.
Sure, sir.
স্যার ইভিনিং এর টাইমিংটা একটু বলে দেবেন?
ইভিনিং এ না 3:30 করো না, কারণ আই ওয়াজ লাকি টুডে, কিন্তু আমার আর একটু দেরি হতে পারে। 4টের পরে করো।
Okay, sir.
4:30 is safe for me.
Okay, sir.
It's
So,
either 9:45. হ্যাঁ।
so can you please discuss the IA's questions, the last two IA's questions?
আয়ের কোশ্চেনগুলো তো তোমরা ভালোই করেছো, ওগুলো
Good.
ডিসকাস করার কি আছে? ঠিক আছে, আই উইল ডিসকাস ইট।
Okay, sir.
Okay, sir.